Welcome to Motorcycle Engineering and Design. In this video I'll be modeling the brake disc assembly. You should be able to follow the same steps but incorporate your own design, and then hopefully you'll have something that looks better than this. And if you appreciate what I do here, leave a like and subscribe for more. So if you don't have any manuals or any real components on hand to take measurements yourself, it's always an option to take some images. Because we're in 3D CAD, we can easily trace these images if we've scaled them correctly, and then we can use that just as reference for dimensions. So here I've done that, and I've got some dimensions for each component of the brake disc assembly, with the exception of the rivets. So these are the dimensions I'll be using for reference. So I'll be using a 310mm brake disc. The braking surface is going to have an internal diameter of 244mm. The rivet is going to be positioned around 220mm, and the fixings will be positioned at 94mm. And then the final two dimensions are for the speed sensor rotor. So with these dimensions we can start modeling. And I'm going to start with the disc carrier, which is the internal piece that's mounted to the wheel hub. We can take a number of different approaches here. Since it's a round disc and we will have some offset, I think the revolve will be the best option. So for the revolve feature, I'm going to draw a sketch which is going to go beyond the point of the internal fixings to give space for the bolt head. So if we have a 94mm diameter, that's a 47mm radius, we need to make sure we can at least fit a 12 to 14mm bolt head. So we'll say 60mm is okay. Okay, so I actually want this surface to be offset, so I'm just going to draw a line at an angle. But in this case I want it to be at a diameter the same as the rivet. So that was a 220, so I would say 110 offset from the midplane. And then, as I said, I want this to be 12mm offset, so I'm just gonna assign that dimension there. Actually, I want a flat surface to meet in the middle of the rivet, so I'm gonna pull this back to say 100, and then I'm going to draw another line to be the flat surface that's meeting the rivet. So usually we add features like rounds at the end of our modeling process, and it's generally safer to avoid using rounds within sketches. So for now I'm going to keep it like this, and I'm going to use surface modeling this time. So I'm just going to finish that sketch, and then I'm going to come into surface modeling. I'm going to revolve this surface around the center. Now we have these surfaces, I'm happy to apply some rounds. So this is the external surface, so when we offset this surface the internal radius is going to be smaller. So we just need to make sure that we give enough of a round here, and I want this to be equal to the radius that we're going to have. So let's offset this now. So now our rounds are consistent. The externals are 20 and the internals are 15mm. So we don't actually need to be working in surface modeling, so I'm just going to change back to solid modeling. So I'm going to go create, thicken this surface by 5mm. So this is our carrier, and we're free to now modify the design of this as we please. So as a visual reference, I'm just going to create a sketch on the carrier to show me where these bolt holes are going to be positioned. and I'm going to say 5 in total. So I actually want to have 5 bolts positioned evenly around this circle, and just to make that easier, I'm going to come in and use a polygon. And if you look at the instructions here, it says that we should select the center point of the polygon, specify a value for the number of edges, and then select the vertex that we want to position it at. So if we come in here, we click the center point. If we input a value now, it's going to set the distance. It's not going to be changing this value here. If we press tab, we should be able to enter here. So that's as long as we let go of the mouse. Enter 5 there, and now we can continue moving the mouse. So this will be my first position here. And just to lock that in place, I'm going to create a construction line just like that, constrained vertically. And then all of this is going to be construction lines, and we may as well make some bolt holes now. Bolt holes are always oversized. We never make a 6mm hole for a 6mm bolt. The amount that we increase that size is usually something like 0.2 millimeters. The more we increase it, the more slop we can introduce into the system, which means that we'll have worse tolerances. Now you see, this is one way that we could do it, by using a pentagon to position our circles. But there is another way we can do it. That is using the circle pattern. So this is going to be a circle pattern. So I'm just going to position the first one at a fixed point using the construction line. We'll say 8.4. So now we can take this and then we go create circular pattern. We've already selected our sketch object. We select our center point, which is here, and then we just specify how many. So we say 5 spread around the circle. So the circular pattern is a feature that we're going to use fairly often throughout this model. So whenever you're modeling, it's always worthwhile also keeping track of the packaging requirements. So in this case, I'm considering the bolt head. I need it to fit on this surface. So I'm just going to put this sketch here for reference, and then make sure that I don't cut any material beyond this point. So I'm going to start with sketching out my design here. I'm going to start with just cutting out the hole in the center of the disc carrier. So as for the rivets, I want them to be positioned evenly around the disc, so we can use a circular pattern for that. But I want them to be in relation to the bolt holes. I want them to be evenly spaced around those as well. So if we know that we need 36 degrees between each rivet, we just need to position it relative to this hole 18 degrees. And you see here that I'm doing an extrude cut, and I've selected all of these surfaces in order to create this cut, but actually you can make one cut and then use another circular feature to do that. So if we take a look at some brake disc designs, usually we'll have a fairly thick inner ring, and then on the outer ring it tends to be quite skinny. And then the variation in design is usually just in the way that they connect the inner ring to the outer ring. So to keep this simple, I'm just going to cut a simple shape out here, which is going to leave a simple strut between the inner piece and the outer ring. So here I've used some construction geometry to help constrain the shape that I'm cutting out of the disc carrier. So once we're happy with the shape that we're cutting out, we use the extrusion. And then before we circular pattern, it would be better to actually apply our rounds at this stage, because we can include those in the circular pattern as opposed to applying 40 rounds individually later on. So now we come in with the circular pattern, and we'll keep this on features, and then we'll select rounds and then the extrusion, the axis, and then increase the quantity up to 10, and then hit OK. So I'm nearly finished with the carrier. I'm just going to add a little bit of detail in the middle here, and then we'll move on. So a lot of manufacturers also try to reduce some material and some weight in the carrier here, so here's my weight reduction. Okay, so including the holes for the bolts, we now have a finished carrier. Okay, so now we can start the brake disc. I've already positioned the origin to the offset of 12mm, so we can just draw a plain sketch on this surface here, or this face. And we can just use the dimensions referenced earlier. So our 310mm disc, and then we'll have a 244mm internal. From here we then need to add in our mounting location. We'll say that the rivet position was 220mm. So this one is going to be just for reference. Then we'll add another circle, say 221mm. This gives us a 0.5mm clearance from the carrier. Now from the circle that we placed to represent the rivet, we can then add a cut here. But then we need to construct some geometry around the rivet hole for our mounting location. I'm going to do that with a construction geometry to use as a mirror plane. We now want to use a circular pattern to copy this geometry all around the disc for the additional 9 rivet locations. And we'll do that by selecting the geometry that we just drew, just the circle and the 2 side walls. And then our center point is going to be the axis here. Increase the number to 10. And then we have our finished geometry. If we finish the sketch, we can now extrude this whole surface and we'll select each one individually. So now we can make the disc just with an extrusion. I'm going to add some rounds, and I'm going to do them manually for each one. The reason for that is you'll often find that when you are trying to put a round like this and then use the circular pattern, the pattern always seems to fail, or at least most of the time in my experience. That also applies to mirrored features as well. I often find that when I'm trying to mirror a round across a plane, it has a problem calculating it. So now we can start thinking about what kind of disc you want to make. A lot of people like wavy discs. These are much better for high performance vehicles. It's not really necessary for on the road. You'll typically find just simple discs like this, plenty enough for the road. There's also the hole pattern. This can sometimes just be circles, or sometimes you have slotted designs as well. So it's up to you how you model it. I'm just going to do something simple with some circles. So I'm going to start with placing some construction geometry. And I'm going to place it 60 degrees because I think I will model one pattern within 60 degrees and then repeat that with a circular pattern around the remaining 300 degrees. Here's after finishing the sketch, just extrude the cut through the disc, and then here we have our final disc. Just need to add the final piece, which is the rivet. We can make this as a single component in one position and then circular pattern that component around the rotor. Okay, so we just roughly model in the final rivet, and then when we come back to the full assembly, we can then create pattern, circular pattern, change the object type to components, select our rivet, select our axes, and then increase this to 10. Now we have our finished brake disc. So just to finish it off, we can come into appearances and then apply all of our different finishes to each component just to help them stand out. Well, if you made it to the end, thank you very much. If you like this kind of format, then please let me know by leaving a like. And if you're interested to see more of this kind of content, then please consider subscribing. And I'll see you on the next one.